So these are three very common, and judging by the number of listings on eBay, these are very popular 3D printer kits available for purchase these days. Now, each one of these can be purchased for under $200, and they are all three of the same general design type, that being the i3 style frame design. Now, I did a review video comparing these two printers side by side. That was actually the very first video about 3D printing that I made, and it was the video that I launched this channel with. But that was a cell phone shot video with no editing done, so I've always wanted to make a better version of that video. Recently, I built up this printer, and it's a very good printer, worth comparing to the other two. So this video here is going to be a side-by-side comparison of all three of these, and we're going to get really in-depth into each one of the printers individually. But you're probably wanting me to just sort of give you the conclusion first here, so I will just tell you which printer is the best. Well, that depends on what type of user you are. If you are a brand new user who has never done 3D printing before, you should get this printer. This is the Tronxy, Tronxy 802E machine. The E machine has the Bowden Tube instead of the direct drive. The direct drive has the stepper motor sitting like this, sitting right on the x-carriage. Now, it's worth noting that these two printers have been heavily modified. I'm doing some pretty interesting things with them, but I've kept all of the original stock componentry, so I will be able to talk about what you will be receiving in the mail. So yeah, this is the best machine to get if you are a beginner. You will get really high quality prints straight out of the box, but you will only be able to print in the lower temperature plastics. If you try to print with ABS, you're going to have problems that require upgrades, and there's sort of impediments to upgrading this machine, so not the best to kind of grow with, to expand and to modify. This machine is the best to grow with. So if this is your second 3D printer, I highly suggest getting this one. Now this one goes by the name of 2017 Upgraded RepRap CTC i3. It's quite the mouthful, but it doesn't really have a brand name associated with it. Maybe CTC, but I don't always consistently see that name when I see this listing. So what you can always look for, though, is the plywood frame, and we'll get into it, but plywood, surprisingly, is the best frame choice here. And so you'll see the plywood frame in the listing photos, and you'll always see an angry bird sitting here on the print surface in the listing photos. So that's the best machine for upgrading. It has a lot of great components that come with it, so you won't need to replace too many things, and of course that frame is a total winner. This is the Geeetech, G-E-E-E-Tech i3 Pro, and it is the best overall machine of the three, with some very minimal modifications, that being a lead screw instead of these threaded rods, and a part cooling fan, along with the upgrade to the firmware. You will need to do that. But with those simple modifications, you will get every bit of print quality that you can get from this one, and this machine here has much greater potential for upgrading and doing fancy things like sticking it into a heated enclosure for printing high temperature plastics and printing them well. This one is $190, this one is $155, and this one is $165. But this one, oftentimes you will find listings that include a make an offer, and if you offer them $145, you're likely to get this one for even cheaper. So let's get into the specifics of each of these printers, but before we do that, I want to give a big shout out and thank you to all of my subscribers. With 5 videos, I got 1,200 subscribers, and that just blows me away. The success of this channel is just phenomenal. And I'm going to keep making these videos, reviewing more and more printers, showing all you guys how to do the modifications to get multi-materials to print, how to make a printer that will work in a heated enclosure. All these things are coming down the pipeline, so make sure you subscribe and hit that bell icon so you don't miss any of those videos. Without further delay, let's get into the specifics of the Tronxy. Let's lay the ground rules for this comparison. I'm going to give each of these printers a score, and that's going to be based on 7 characteristics that the printers all share. And those characteristics are the frame, the x-carriage slash extruder mechanism, the bed, the mechanicals, including the Z-height mechanism, the stepper motors, which sit here, and these are a couple of ones sitting beside, and also the board, the control board, and the display. Those are 2 separate characteristics. So diving right into this one, I'm going to give the frame a 2 out of 5. And the reason for that is if I grab it here and I grab it here, you can see how much flex there is in this frame. And that actually is going to be pretty important once you're printing up high. Now I've put this printer in a fairly high orientation to sort of illustrate what's going to happen. If you're printing at a high print speed and this x-carriage is getting thrown back and forth, you see the printer flexing? Well, that's the weight of that getting thrown back and forth will cause the frame to flex up high. So if you can see it with your eye, that means that you're definitely going to notice the print quality in your walls as it prints taller and taller. So no good at all. Now there's another reason that frame isn't any good. These stepper motors have been upgraded. These are the original stepper motors right here, and you can see how much taller the upgraded stepper motors sit. Now if you don't want to upgrade, you won't ever have a problem with the stock stepper motors that came, but I had a problem because they weren't powerful enough to lift some of the 3 color printing heads that I'm experimenting with. And if you want to upgrade to those larger stepper motors, you will have to either print some feet for the frame or maybe do like I've done and put some foam underneath the frame just to keep it sitting flat. So to illustrate why that's the case, let me do this. And now you see the printer can rock, and that's just because it's sitting up high on these steppers, because these steppers, the new steppers, are taller. So not really easy to upgrade the stepper motors on this frame. Okay, let's put this back. So because of those 2 reasons, the fact that you cannot easily upgrade the stepper motors and the fact that it has so much flex, the frame gets a 2 out of 5. It's pretty bad. Moving on though, let's talk about this extruder mechanism, the whole x-carriage. And we'll take a better look at it over here. This gets a 4 out of 5 because of, well, 2 main features. One is the part cooling fan, this blower mechanism, and the other is because it has these slots already pre-drilled into it, ready to receive the sensor for auto mesh bed leveling. Now, if you install this sensor, you'll need to upgrade your firmware, but that's not too difficult. And well, this sensor did not come with it. I just installed it here to sort of illustrate how it would go on, and you can see how you adjust the height there. But let's talk about the other features to this whole x-carriage. There's a drawback to the x-carriage, and this is reason number 1 why you will have problems printing in high temperature plastics. This is the extruder cooling fan, and it mounts right there like that. You see all of that extra plexiglass or acrylic that's blocking about 40% of that fan. So you're only getting about 60% of the potential cooling energy coming off of this fan. Now that'll be okay at your low temperatures, like when you're printing PLA, but when you get into the higher temperature plastics, you really need to aggressively be cooling that extruder, and well, I don't think that's going to do such a great job of it. So that's kind of a demerit. So yeah, another thing I really don't like about this one is these little slots are how you loop the belt, the sort of control belt. You loop it back through there and zip tie it together, and that's how you get those. Just didn't really like it. It seemed sloppy to me. Also, this extruder is an E3D V5. And for comparison, here is an E3D V6. And the E3D V6s are definitely an upgrade. They have improved throats on the inside, and they have the same surface area in the number of fins. In fact, there are 11 fins on this one, where there are only 10 fins on that one. So there's actually probably more surface area for cooling on the smaller part here. But that smaller part also gains you about that centimeter's worth of Z height. So your prints can now be a centimeter taller. So all in all, the E3D V5 is kind of antiquated, and I don't know why they're still making these. So all that being said about this whole x-carriage extruder assembly, it still produces some fantastic prints straight out of the box. Now, if we look at the print here, this is a test cube, a 1 centimeter by 1 centimeter by 1 centimeter test cube. And this is one of the vertical walls. And just look at the beauty. That is just such a great print. You see these, this is the lines going this way are the print layer lines, and then you have 2 lines that go vertical. And what those 2 lines are is internally the support structures meeting up with the external walls, and that just makes that little divot there. So that's nothing tragic. Here's the top, and here's the bottom of this this part. And so you can see that these are pretty great parts that it produces. Now this is PLA plastic, so it's very low temperature, and I've gotten some luck printing in PETG. But you will not be able to print very high plastics, first of all because of this blockage on the fan cooling the extruder, but secondly because of the bed. Now let's move on to talking about that. The bed in this case is an all aluminum bed. Now I've added this PEI sheet to it, and that gives me a really good bed adhesion. As you receive this printer, you're expected to use masking tape or hot glue or maybe some hairspray, all the different techniques for adhering parts to your bed surface. And that aluminum bed is nice because the sensors, the proximity sensors, will detect the aluminum, but it does have a problem because it's basically a giant heat sink. So that means that your heating element is working very hard to heat up all the aluminum. Now the aluminum disperses the heat nicely, so you have a real evenly heated bed surface, but because it has to work so hard to keep that heated, it puts a lot of strain on your board. Now what happens is the electricity comes from the power supply into the board and out of the board into the bed. And when the bed is sucking up so much juice just to keep it hot, the board can't handle it and it automatically shuts down. And I find the automatic shutdown happens at about 88 degrees. And looking on the forums, people with ANET A8s have the same problem at about the same temperature. So what's the solution? Well, you have to upgrade the printer. You have to buy a MOSFET kit and hook that up, which makes the power basically go straight from the power supply into the bed, but the board is still able to control the temperature of the bed with a MOSFET. So there is a solution, but it's not elegant and it's kind of hokey. So the bed will only get up to 88 degrees in stock configuration, which means you won't be able to print ABS, which requires a bed temperature of 100 degrees. So the bed gets a score of 2. So moving on, mechanicals. Here is the lead screws. Now these are a great feature on this printer, and these combined with all of the features on the x-carriage that we talked about, the lead screws are primarily responsible for that great print quality that you get. Lead screws have a special profile to the threads, which is square, and that means that you get very accurate prints without what's called Z-wobble. And yeah, so these are great, but I have to sort of get some demerits on the mechanicals for these 3D printed parts here on the Z carriage. Now these were printed, and I can feel it with my finger right across here. They were printed with this side down. And what happened is it got some peeling. So as it printed, the corners, just like my fingertips there, the corners peeled up. So what you ended up with is a part that's rounded on the bottom instead of sitting perfectly flat on the bed. Now, unfortunately, this T-nut has to mount and screw onto that rounded corner. So that twists the T-nut at an angle, and you get a lot of binding between the T-nut and the lead screw. So I had to put these shims of paper in there, and I just kept adding pieces of paper until I didn't have any more binding. So I got it to work, but I shouldn't have had to do that, and that's just pretty hokey, having to add paper spacers to your mechanicals. So other than that, mechanicals are pretty decent. The metal pulleys here, it's a little annoying that they're so much larger than the pulleys that are actually on the motor. Now, functionally speaking, it doesn't seem to have much of an effect. It's the same story here on the y-axis. And what I would have really liked to see here on the y-axis is a tensioner. So, and also a tensioner for this pulley. So those also give the mechanicals some demerits. Total score for the mechanicals, 3 out of 5. And that's pretty much just because of these lead screws. And yeah. So moving on, let's talk about the stepper motors. And we already talked about why I needed to replace these Z stepper motors, and you probably won't need to. So stepper motors could function in the stock configuration for you just sufficiently. But if you want to do any upgrading, these are not up to par, and they will not do the job for you. So I got to give the stepper motors a 3 out of 5 here. They just aren't strong enough. Okay, now the board. This is what's called a Melzi 2.0 board, and it comes with this AT1284 chip on it, and that is definitely not as good as the ATmega 2560 chip, which we will have on our third printer that we'll be looking at. Also, if you get like a Ramps 1.4 kit, you would get that upgraded chip. Now, the processing power on this is lower, so depending on what you're trying to do, if you upgrade the firmware, it might or might not have enough processing power for you. But as it comes stock, it does just fine, and it does everything you need it to do. The biggest drawback to this board is the integrated stepper drivers. And so if one of those happens to get burned up for some reason, probably something you did, but you won't be able to replace them. And then also you cannot upgrade them. Now, other boards have replaceable stepper motor drivers. So let's say you want to increase the resolution of your print by giving it a stepper driver that can do finer steps. You can't do it with this board. So yeah, I don't like this board, and it's pretty unpopular in the forums. So I'm going to give it a 2 out of 5. Okay, so the display for this printer, it has these 5 buttons, and those are how you navigate through the menu. Now, I'm not a fan of these, so also the display could be larger, so 2 out of 5. Pretty self-explanatory there. So yeah, that's the Tronxy. Let's move on to the Plywood printer. So this is the Plywood framed CTC printer. And well, let's just go right down the list and give it its ratings. The frame gets it a 4 out of 5, and that's a very high mark. And the reason for that is that plywood has a very low thermal expansion coefficient. It means it doesn't move in the heat. It does move a lot with humidity changes, but this plywood has been coated on both sides with a very thin layer of melamine. And that's the same material that your countertops or your click laminate flooring is made out of. So it's a very tough material if you don't chip it off. So yeah, it's going to be a good printer that resists humidity and temperature. That's a really good frame. So 4 out of 5, that's the highest mark of either of these, all 3 of these printers. And also, you know, it does not flex. It has that single front panel, so if I grab here and there, obviously I'm not getting any movement out of that frame. So it's a really, really sturdy frame. Let's talk about the extruder slash x-carriage assembly here. Now, this is the original extruder, and this is the original fan and heatsink, but this lever arm, spring-loaded lever arm, was not included originally. What you did have was this unit. And there, if you can see inside of here, you can see this pulley down inside of there. And so just with the sort of flex that you would get in the plastic, the pulley was held against the drive wheel on the extruder. So it surprisingly did a good job, and I never had any skipping issues. But just looking at the design, you tend to sort of give it a demerit. But hey, it works, so it's hard to discount it. And the extruder here is quite robust, everything you need. And this bracket here is metal, so that's nice and temperature resistant. So yeah, all in all, the extruder mechanism was pretty good. And the best thing I can say about it is that it is an all metal extruder. Well, that means that you can print very high temperature plastics. With your PTFE liners that come on the other extruders, you won't be able to get to those extremely high temperatures. So the all-metal extruder gives it kind of a bump too. So all in all, I'm going to give this just a slightly less of a score than I gave to the Tronxy, and that is going to earn a 3 out of 5 stars. Now, the big problem with this extruder is that it does not, or with this whole carriage, is that it does not come with that blower to act as a part cooling fan, and that's really necessary. So you will have to add that on. Not the hardest upgrade to do, but you definitely need to buy one of those to get good print quality. So speaking of print quality, let's take a look at the cube that I printed off in the stock configuration without a part cooling fan. So ignore the little jagged, the zigzag here. That was my fault. I tensioned down the belts mid-print. You see those lines in the, those wavy lines? Now what those are is, that's your Z-wobble, the Z-wobble that I talked about. Also, you see these devil horns kind of popping up off the off the top. Now this is the top and this is the bottom, and these little devil horns pop up off the top, and that's basically caused by the lack of a part cooling fan. And this is PLA, the easiest plastic to print with. So imagine trying to print with your ABS or PETG, you're going to have much more of a problem with that. So yeah, it's absolutely just bonkers that these things don't come with a part cooling fan. So you'll have to add that. So let's talk about the bed now. This here is a sheet of glass, and I have coated the backside with aluminum foil. So when you receive that in the mail, it will just be clear glass. Now underneath the glass is this PCB bed heater that's made out of fiberglass and the copper from the PCB. That does a great job of heating things, and the glass provides a really nice smooth surface for printing on. Some people, if they clean the glass very well, can get a print with just the raw glass using PLA plastic. I never have quite been that successful. I always use glue stick. You could also use hairspray, or if you're printing with ABS, you would probably put down some masking tape to really get that print to stick to the glass. One great thing about the glass coming off is you could take the print bed off, spray the glass with hairspray outside of your printer, and then put it on there. So some people swear by hairspray as their adhesion method of choice for that first layer, and that provides a nice clean way to adhere the hairspray to the glass. So I like that. So the bed gets a 3 out of 5. All three of these bed heaters are kind of an old design. Prusa came out with these things a number of years ago, and they could certainly be more powerful. Now I am able to get this bed up to 100 degrees, but I have not tested it farther up than 100 degrees. So can't speak to it above 100. And it is pretty slow to get to that 100 degrees. So I just need more power out of my bed to get a higher rating there. So the mechanicals of this printer, they're pretty bad. They earn a score of 2 out of 5. And the primary reason for that is these threaded rods that go in place of the lead screws that you saw in the last printer. Now, taking a look at these threaded rods, we can see there's a much finer thread pitch, but so that should theoretically be nice to help the motors, the weak motors, lift the Z-axis. The problem is these do not have a square profile to the teeth, so that angled profile in a typical thread does not lend itself well to accuracy. You get the Z-wobble that I was just showing you on the test cube. Also a problem with these threaded rods in this design is this acrylic, I'm sorry, not acrylic, this is a vinyl tube that they're using as the flexible coupler. So if we look back at the big machine here, we see these aluminum flexible couplers, and those are kind of a much more elegant solution. But this is a much cheaper solution. And so with this whole design of threaded rod with the vinyl tubes, this whole thing is a throwback to about 5 or 6 years ago when all of these parts weren't available so cheaply from China, and they were trying to keep the costs down on these 3D printers. I believe that this was a Prusa design, and well, it's pretty antiquated at this point. I have no idea why they're still even making parts like this, but they are. Also, a problem with the mechanicals is the plastic parts here. Those will not do well in the heat. Now I do have to give them credit. They used, you can see there's remnants here, so they used masking tape to hold these to the print surface as they were printing them, which means that these surfaces are completely flat. So that's good. That means I didn't have any binding issues with the T-nut on the threaded rod. But the big problem with the mechanicals is these plastic pulleys. Let's take a look over here. If you see when I rotate the plastic pulley, let's see if we can get a good view of this. You see the increase and decrease in the gap between the pulley and the red. And what's happening there is that the pulley is sort of oblong, and so it wobbles. And as it wobbles, basically it's not as accurate here on the belt. So as this stepper motor tries to pull, and it's thinking it's pulling just a certain amount, depending on the wobble, it could be pulling more or less. And so you're going to lose accuracy there. That's going to exacerbate the sort of Z-wobble problem that you have. So those are the second worst part next to the threaded rod of the mechanicals. Those have got to go. So yeah, mechanicals get a 2 out of 5. Steppers. The stepper motors on this printer are great. They are all large and extremely powerful. So stepper motors earn a 4 out of 5. Okay, the board. The board that comes on this printer is this 2560 board. It says 2560 right there. Can you see that? But it's a lie. This is not, in fact, a GT 2560. It's sort of a clone copycat thing. And the reason I know that is because if you look at the writing on this chip, it says ATmega 1280. So it's similar to the Melzi board. That's a lower chip than the 2560. So if you try to upgrade the firmware on here, you might run into processing issues. Now, these slots 1, 2, 3, 4, 5 all receive the stepper motor drivers. So you can definitely upgrade stepper motor drivers. So that's a major benefit. And also, the fact that there's 5 of them means that you could potentially upgrade this to be a dual printing printer. Like you could have either 2 hot ends, or you could do a 2-into-1, and you would have enough stepper drivers for that. So that's another major upgradable feature to this board. So not a bad board. If it wasn't for the AT25 or 1280 instead of the 2560, I would give it the full 4 out of 5 stars. But you know, I have to, because of that, I have to kind of demerit it. Now, the big problem with that chip, though, is the difficulty in getting your Arduino IDE programmer to actually upload a sketch to this. Apparently, a lot of people have problems when trying to upload. But yeah, I'm going to give this one a 3 out of 5. It could be better, but it's pretty good. You can definitely upgrade with it, and you might be able to get it to work. The display that comes with this board is really great. It's got the push button knob, so that's how you navigate through the menu. Really like that display, that knob, so that gets a solid 3 out of 5. And the reason it's 3 and not 4 is because, well, I would like to see the larger display on these printers. So all things told, this printer earns a 22 points relative to the 17 points that the Tronxy earned. And finally, we have the G-Tech. Now, I hope you can see that it says G-Tech i3. And let's just run down the scorecard for this one. So the frame gets a 3 out of 5. It's very stiff. It does not have any flex like the Tronxy did, but it is also made out of acrylic. However, it is a thicker acrylic, so this one might do okay in the heated enclosure because it is so thick. I'm going to have to do tests with it, in which case I would up it to a 4 out of 5. More like a 3.5. The plywood is always going to be a little bit better, but pretty good frame. Pretty good frame. Okay, so the extruder. The extruder here is an all-metal hot end, which is great, and it has this spring-loaded mechanism to keep good tension between the tensioner bearing and the feeder wheel on the stepper motor. So that's nice. And in general, you know, it's just a bunch of metal componentry which won't go anywhere. It's very solid. So really great sort of extruder mechanism going there. That gets a 3 out of 5 also. So the one thing I have to say bad about the extruder is it does not come with this blower. Now I've installed the blower fan afterwards, but it doesn't come with it. So that's why it gets a 3 out of 5 instead of a 4 out of 5. Now with the blower fan, 4 out of 5. Everything's great about that. So the bed, it's the exact same bed as what was on the Plywood printer. So yeah, 3 out of 5 for the bed. And you know, what can you say about it? It's pretty great. Now you can see on this one, you can see through the glass to the bed because I didn't put the aluminum foil backing it. The mechanicals get a 4 out of 5. These are fantastic mechanicals. So from the metal pulley, that's the same diameter as the pulley wheel on the motor. That's fantastic. You have them here as well. You have tensioner, these wing nuts to tension the pulley, so you can just get just the right tension on your belts. And it would be a full-on 5 out of 5 if only these were lead screws instead of threaded rods. But again, they went with the threaded rods. Now, to their credit, they did use the much better aluminum flexible couplers instead of those vinyl tube sections on the last printer. The stepper motors get a 3 out of 5. Now, they're adequate for the job, but these two steppers in the Z direction are short. Now, that frame is built so that it can handle the steppers. See, I can get my finger up underneath there, which means that you can definitely install larger steppers, which might be necessary when you upgrade the the threaded rods here to lead screws, because like I said before, those lead screws have a much more aggressive thread pitch, which means that you need more strength out of your stepper motors to lift that Z carriage. So let's turn this and we can look at where the board sits. Now I've modified this to take this large, I think it's a 120 millimeter fan. Now normally they want you to mount a little tiny little fan right here to blow on the board, and I didn't like the noise that smaller fan makes. This is much quieter, and I also like the better air circulation. So I've designed and printed up this whole part here, which sort of covers my board and just keeps everything neat. It also gives me a mounting point for these, these spirals of cable. And so this is just a clean solution, and you can't quite see the board, but it is a genuine ATmega 2560. So that is the genuine deal GT 2560, and I will show you a picture of it right here so you can get an idea. Now it does have the real 2560 chip and all of the other benefits. There's some fuses in the top right corner, and just the ability to put your 5 steppers on there. So let's look at that. You have a single stepper slot that gets taken up for these 2 Z motors, and they're both run off of the same driver. They basically mirror each other. They do exactly the same thing. So that's 1 stepper. You have the X stepper, that's 2, and you have the Y stepper, that's 3. You have the extruder, that's 4. So with the 5th stepper, you can add a 2nd extruder. So you can print in 2 colors without even upgrading the board. All you need to do is put some sort of a splitter or 2 nozzles or any of that kind of thing. So let's take a look at the test prints here. Now this was the very first test print that I did on this machine in stock orientation. So this was without the, without this part cooling fan, without the blower. And if we take a look at this, what we can see is here's the bottom, nice and smooth, reflecting the light there. Here's the top, and you can kind of see the support material inside of this clear. I printed this with clear ABS, but if you'll notice from the top there, these sides sort of cave in. You also get the devil horns, the same sort of horns popping up off the corners that I showed you from the last printer. And so it's just overall, it's just kind of, you suffer from bad print quality. You really need that part cooling fan. Now this, like I said, is just some PLA plastic. This is the easiest plastic to print in, and if I'm getting these problems already with PLA, they're going to be much worse printing in, well, almost any other plastic. So from your PETG to your ABS. This is the test cube as you're seeing it with the part cooling fan. And if you look really closely, let's just pick a side here. Here we go. You can see all those lines that appear, and those are parallel to the layer lines, but they are not layer lines. Those are Z-wobbles. So that's just variation as you go up the print. Now, so let me grab one of these printed rods, and I'm going to hold it up to here, and you can see the Z-wobble lines up perfectly with the threaded rod. So the thread pitch of the threaded rod corresponds to the Z-wobble. So that's just clear indication that that problem comes from these threaded rods. Now, there are patches. Somebody inevitably is going to pop up on the comments here saying, there's a solution to the Z-wobble, there's all these things that you can print and spring-loaded blah blah blahs. You know what? They may or may not work. I'm not going to try them. I like to address the core root of a problem, and that is replacing these threaded rods. The display here, and I'm actually going to be able to show you this time, this is how it works. You can scroll up and down the menus. Let's go to prepare, and we can move axis. We'll move that Z here a little bit. So, that's how it works. So it's just so nice to be able to just scroll through the menus with just this knob, just like that. It's so fast and so pleasant. So the knob, and the display's a little bit small. If the display was the bigger display, it would get a 4 out of 5. But yeah, so I'm going to give the whole display there a 3 out of 5. So total score on this printer, 23 points. Total score on the Plywood version was 22 points, and total score on the Tronxy was 18 points. So there you go. This one narrowly beats out the Plywood, although if it does perform well in the heated enclosure, I would say it's a definite upgrade to the Plywood one. So. Well, there you have it. There's a whole lot of information about these 3 printers, and I hope you found it useful. Now in the future, what I plan to do is to keep making these review videos on these low-end Chinese 3D printers. There are Delta-style designs that I want to review, and cantilevered designs where the x-carriage sort of cantilevers out over the bed without the support on this side. And there are also aluminum extrusion versions of these i3 frames that are very interesting as well. So I would love to review all those, but I need to purchase those printers first, which is where you come in. Follow the link right here or down below in the description, which will take you to my Patreon page, and please donate to the channel. It will help me to make these videos. And also, if you are interested in the process of making multi-material prints happen, or in how to make a printer that you can use in a heated enclosure, I will include 2 links right here to those video playlists. Thanks for watching.